Hello everybody. Today we will continue our universal dimmer series and we will talk about the implementation of the driver for the MPDM version 4 universal dimmer board with the Arduino. I know a lot of people were waiting for this one, so that's it. What we will use today in our setup, it's the MPDM version 4 universal dimmer board that you know already. I have also here a small Arduino compatible board. Actually it's an Arduino mini and a serial to USB adapter, and of course an AC 24 volts mains light bulb. So regarding the setup, as you can see, the wiring is very simple. So from the Arduino board I'm using pin 3 for generating some PWM signal, and their connections are just the ground and the voltage. In this case, the Arduino board, it set it up at 3.3 volts, but it's working the same if you have a 5 volt one. I've done it with 3.3 volts because all the other examples are based on the 3.3 volt logic level voltage, and I'm trying to keep it consistent through all the examples. Yeah, so very simple. What you can see, let's say a little bit extra here, from the pin output where we have the PWM signal, I've just connected a capacitor and two resistors to just create an extra smoothing filter for the PWM signal before sending it to the V control pin of the dimmer board. Yeah, so that's it. Let's go to the software side and let's see how easy or complicated it's to use it. On the software side, we have here a very simple example. Actually, what are we doing here is to read some data from the serial port, and we will take this value and interpret them and convert them in the values that will be sent to the PWM pin. Yeah, so basically, as you can see, what we have here, we have defined the V control pin. It's the pin where the MPDM version 4 V control pin is attached to. In our case, as I said, I was choosing pin 3. We are defining also the brightness as a byte, so it will take values between 0 and 255. Where 0 means 0 and 255 obviously means around 3.3 volts. In our case, we defined, let's say, start default value of 230. This will give us to the beginning, when we are resetting the board, the let's say the light bulb in the off status. So when we are pressing the reset button and we are resetting the board, basically the light bulb will stay in the dim status, in off status. Yeah, if you put here, for example, 0, every time when you restart the board, it will go full on. Okay, on the setup, stage we are defining our serial communication. So we will choose this time to communicate at 9600 baud. We will initialize the vControl pin as an output, and we will set the default brightness value that we choose before. So we will just send it as an analog write on the vControl pin, obviously to generate the PWM signal. And now the program, because I don't know how to say, for some people it's fortunately, for some people it's unfortunately, but I think it's fortunately. The entire program to be able to run the universal dimmer board, it's this one. We are just checking on the serial to see if we have available new data. If we have new data, then we will choose the new value and put it in the brightness variable, and we will do another analog write on the vControl pin. So we will update the PWM signal on the vControl pin if you want, and that's it. Yeah, that's it. So let's see how it's working. I've done some changes, hopefully everything is okay. So sketch is compiled, now it's uploading. It's done, and let me go just a little bit closer to the light bulb. Okay, now let's try to send some values. As I said, 0 must be full on. Okay, now you can see the light bulb, it's full on. We said also that 230 it's full off. You see now it's dimming, and it's off. What I want you to see when I'm jumping from full on to full off, it's that, as you can see here, yeah, now it's a full on. Every time when this thing is doing, it's done with a very smooth and in stages. Yeah, it's a little bit delayed. Why it's important? It's important especially when you are going from, you see now we are full off. If we are going to full on, look what's happening. Have you seen it? It's ramping slowly. Yeah, why is this important? It's important especially on high wattage light bulbs, because this is one of the best ways to avoid big inrush currents. Yeah, so as you probably know already, when the light bulb is cold, it has a different resistance than when it's warm, and from there you can start having a lot of problems. It's an entire theory behind, and obviously it's not here the place to start talking about. But what I want to show you is that it's ramping very slowly, and because it's doing this, this will help you to protect the light bulb and to protect the circuit, and also to avoid the big inrush currents. This thing is happening in hardware, so as you can see on the software side, it's nothing defined here, so we are not doing a software stepping. We are just doing our proper analog write one time, and the hardware will take care of it. Yeah. Now let's try also some different values. So let's go back to full. we are on full 100%. Now let's choose 150. It's already become dimmer. Unfortunately, because of the camera, it will be easy to see, let's say, the last part of the interval than the first part because of autofocusing and auto exposure and things like that. So 180. Now probably you can start seeing it going dim. 190, even further, 200, 210. Yeah, now I think everybody can see the difference. As you can see, the transitions are very smooth, and there are no let's say jumping, there are no steering. Everything, it's going very smooth from one level to the other one. Yeah, let's try to go a little bit back. 170. Now we are going back to 210, 220. Now you see it's very dim. You can actually look at the light bulb filament. And 230 will put us to the end of the interval. Okay, so this is a very simple example with Arduino and with Arduino board and using the Arduino IDE. I'm insisting on this thing about using the Arduino board and Arduino IDE because you will see in the future we will have also examples with others MCU using the Arduino IDE. That's all for now. If you like it, as usual, please give me a big thumbs up. Thank you very much, and see you next time.